Hey everyone, it's Tim. I just wanted to create a couple quick videos, one going over t-test and the other going over confidence intervals. This is going to be very similar to what we did in class. So the first thing we want to do when we're thinking about doing a t-test between two groups is I like to get the average, the means or the averages for the two groups as well as the standard deviations to get a grasp of any differences that might be going on. So I would go equals average and then A2 to A37 because that is the block of cells that I'm interested in for class 1. And then I'd do the same thing for the second class. And again, when you want to get the mean, you type in equals average. And I get a mean of 3.29 and 3.31 essentially. Now, if I want to get the standard deviation, I go stdev.s, then A2 to A37. For the second group, stdev.s, B2 to B37. So now I have the means and the standard deviations for these two groups. And just from eyeballing it, it seems that the means are very similar to each other, and the variability shown in the standard deviations looks like there's a lot of overlap between scores. So remember that standard deviation talks about the average deviations from the mean, and that one standard deviation plus and one standard deviation minus encapsulates 68% of the data. We see here that one standard deviation above this mean is about 3.67, which encapsulates this mean. So on the face of it, it seems like these groups are pretty similar and that there isn't a statistically significant difference between the groups. In your homework, I ask you to calculate the means and standard deviations for the 4 classes and then to hypothesize if there's significant differences between the two groups. So is there a difference between A and B, A and C, A and D, B and C, B and D, C and D? So do any of these differences look statistically significant just from looking at the means and the standard deviations and how far apart or how close they are? I'm not expecting you all to get exact guesses correctly, but hypothesize in your homework. So that's what I mean here. So back to this, let's calculate our t-test to actually see whether there is a significant difference. So for this, all we do is type equals t-test, and then it asks us for array 1, array 2, tails, and type. Our first array is A2 to A37. That is our first group. Our second group is B2 to B37. What it means when it says array is group or whatever marker that you have here. So array 1 essentially means group 1, array 2 means group 2. Everything we do in this class is going to be a two-tailed distribution and a two-sample equal variance. So whenever you run a t-test for homework, put t-test, the first group, the second group, and then comma 2, comma 2. So when they throw out options, when they say one tail or two test type, one tail test or two-tailed distribution, type in 2. And then for this one, it'll say 1 equals paired, 2 equals two-sample equal variance, 3 equals two-sample unequal variance, type in 2. And we get a p-value. This gives us our p-value of 0.87, which is not statistically significant. So again, if we're going off of an alpha level or a significance level of 0.05, that would mean that our difference here is vastly insignificant. So it is not even close to 0.05, meaning that there is not a statistically significant difference between this class 1 and class 2 GPA. Now let's do another example together. So now we have test scores for class 1 and class 2. Let's see if they're significantly different. So again, I do mean and standard deviation for both groups to just eyeball and get a rough guesstimate as to whether there's going to be a significant difference or not. So again, I go average A2 to A31 equals stdev.s A2 to A31, and I get the standard deviation, and then I do the same thing, average B2 to B31 equals stdev.s B2 to B31, and again, I get my means and standard deviations. Again, so if you go to Canvas and you look at the Excel sheets that I posted, if you click on these cells, you can go back up to the top and see the commands to see how I calculated things. So for here, I did stdev.s b2 to b31. So again, I'm looking at my means, I'm looking at my standard deviations, and on the face of it, I would not think that these are statistically different from each other. The means are rather close, and the standard deviations are so wide that it makes it seem like the variability within the groups is bigger than the variability between the groups, which is what a t-test gets at. So let's calculate our t-test p-value. So we go t-test array 1, which is A2 to A31. So again, array 1 is our first values, comma, array 2, which is our second values, which is B2 to B31, and then 2, 2. So just after you type in two arrays, type in comma 2, and we get a p-value of 0.61. So again, is not statistically significant, which is not surprising given the fact that we looked at our means and standard deviations already and found that our that they were pretty close. So again, if the t-test was significant, we would have got a p-value of less than 0.05. So it would have been 0.04, 0.03, or 0.01. So that is how we calculate t-tests, and that is how we go about understanding what a t-test means. So as we talked about in class when we compared critical values to t-values, Excel is very nice because it simply gives you the p-value so you can easily make an assessment of whether it is lower or higher than our alpha level of 0.05. All right, thank you everyone.